and welcome to Circuit Analysis Solutions. Now we are asked to find the equivalent resistance between A and B. First of all, we know that whenever resistors are connected in series, their equivalent resistance is equal to the sum of two. For example, two resistors are connected in series, their equivalent resistance is equal to the sum of two. And if the two resistors are connected in parallel, we know that then the equivalent resistance is equal to 1 divided by R1 plus 1 divided by R2. And if I simplify this, then the equivalent resistance in parallel will be equal to R1 multiplied by R2 divided by R1 plus R2. Fine. So you need to keep these two things in mind, that the equivalent resistance in case of series is simply equal to the sum, and equivalent resistance in case of parallel is equal to the multiplication of the two parallel resistors divided by the addition of the two resistors. Now we are given a circuit over here and we are asked to find the equivalent resistance. Now what we need to do is to start from the opposite side, which is this side. We are going to find the equivalent resistance between A and B, and we are going to start from the opposite side, and we are going to be very vigilant with the series and parallel combination. So if you can see over here, this 1 kilo ohm resistor is in series with this 2 kilo ohm resistor. So I can replace these two resistors by a simple 3 kilo ohm resistor. Fine, I am going to replace these two by a simple 3 kilo ohm resistors, and that's what exactly I have done over here. I have written all those again, and I have replaced these two by 3 kilo ohm resistor because these two are in series. Now let us look again. Now this resistor and this resistor, on one side they are connected to this node, and on the other side they are connected to this node, which means that these two resistors are in parallel, because on one side they are connected to this node, on the other side they are connected to this node. So these 3 kilo ohm and 6 kilo ohm resistors are in parallel. So now their equivalent resistance will be equal to the parallel combination of these two. And what is the parallel combination? We simply have to multiply both, which is 3 multiplied by 6, and then divide by the sum of both, which is 3 plus 6. Fine. 3 kilo ohm multiplied by 6 kilo ohm divided by 3 kilo ohm plus 6 kilo ohm, and that equivalent resistance comes out to be, because this is 18 divided by 9, so that comes out to be 2 kilo ohm. So I can replace these two resistors by 2 kilo ohm, and now I am going to do it. I am going to replace this 6 kilo ohm and 3 kilo ohm resistor by a 2 kilo ohm, because their equivalent resistance was equal to the 2 kilo ohm. So what I am going to do is simply place a 2 kilo ohm resistor over here. Fine. Now if we can have a look, this 10 kilo ohm resistor and this 2 kilo ohm resistor are in series. So they are in series, and in series resistors are added. So now I can replace this resistor by 12 kilo ohm. Why? Because 10 plus 2 is 12 kilo ohm. I'm going to again rub this thing off, and I'm going to simply say that this is now 12 kilo ohm. So this is my, I will write it over here. Okay, this is my 12 kilo ohm resistor. Again, if we can have a look, this 6 kilo ohm and 12 kilo ohm resistors are in parallel. Why? On one side they are connected to this node, both are connected to this node. On the other side both are connected to this node. So these two are in parallel. And again, for the parallel combination, we have 6 multiplied by 12 divided by 6 plus 12, and 6 multiplied by 12 is 72, and 6 plus 12 is 18. So again 72 divided by 18, that comes out to be 4, which means 4 kilo ohm. So now I can replace these two resistors by a simply 4 kilo ohm resistor. So I am going to replace these two resistors by simply a 4 kilo ohm resistor. I am going to rub this thing as well, and I am going to name it as 4 kilo ohm resistor. So this is my 4 kilo ohm resistor. Okay, let me remove this as well so that you do not get confused. Okay, now if you can see over here, again this 4 kilo ohm resistor and this 2 kilo ohm resistor are in series, so they will be added. 4 plus 2 is 6. So I am going to raise these two, and I am going to simply connect a 6 kilo ohm resistor over here. Okay, so I have connected a 6 kilo ohm resistor over here. So this is my 6 kilo ohm resistor. Fine. Now again, on one side both the resistors are connected to this node, on the other side both the resistors, this was my node, sorry I have drawn the node not right. Let me draw it bit better, a bit appropriately. Okay, this is my 6 kilo ohm. So on one side they are connected to this node, on the other side both these 6 kilo ohm resistors are connected to the other side, which means to the other node. You can see over here, which means that again these two are in parallel, and again in parallel you need to multiply both of the resistors and divide by the sum. 6 multiplied by 6 is 36, sorry this is 6 plus 6, okay, and 6 plus 6 is 12. It's 36 divided by 12, which comes out to be the 3 kilo ohm, because it is in ohm. So in place of these two resistors I can simply replace a 3 kilo ohm resistor. So I'm going to do it. I'm going to remove these two and I'm going to simply place a 3 kilo ohm resistor over here. So this is my, for example, 3 kilo ohm resistor. Fine. Now have a look. This 9 kilo ohm resistor and this 3 kilo ohm resistors are in series. Why? Because they are in series. Same current flows here. So they are in series. Fine. So I can replace this by a 12 kilo ohm resistor. So I'm going to replace these two resistors by a 12 kilo ohm resistor. Fine. So I'm going to connect a 12 kilo ohm resistor over here. Now again on one side these 4 kilo ohm and 12 kilo ohm resistors are connected to this node, on the other side they are connected to this node, which means that they are in parallel. Fine. So now they are in parallel. I am going to take the parallel combination. So 4 and 12 parallel combination, 4 multiplied by 12 divided by 4 plus 12. 4 multiplied by 12 is 48, 4 plus 12 is 16, which comes out to be 3, which means 3 kilo ohm. So I can replace these two resistors by 3 kilo ohm. So I am going to remove this resistor. I am going to connect a 3 kilo ohm resistor over here. Now the resistance between A and B is clear. Now we again have a series combination. So 2 plus 3 is 5 kilo ohm. So the resistance RAB is equal to, because these are in series, so this is 5 kilo ohm. So we have 5 kilo ohm resistance. Equivalent resistance between A and B was 5 kilo ohm. Hopefully you understand this question. If you have any question you can ask in the comment box. I will be more happy to answer your questions and your queries. Thank you. Please subscribe to the channel.